Most TypeScript function bugs are not complicated. They come from one unclear contract, the wrong callback shape, a missing default, a lost this value, or overloads nobody can reason about. In the next 8 minutes, you will learn a simple decision system for all 4 and test it twice with real code. Begin with the 3 common forms. A function declaration is hoisted, so code can call it before its definition. A function expression is assigned to a variable and is not usable before that assignment runs. An arrow function is also an expression, but its most important difference is that it captures this from the surrounding scope. Choose the form for its behavior, not only its appearance. Think of a function signature as a contract. It should answer 4 questions. What inputs are allowed? What output is promised? Does the function depend on a particular this context? And how can the call vary? Most mistakes in this chapter happen when one of those answers is missing or needlessly complicated. Type inference is useful, but an inferred return type follows the implementation even when the implementation changes accidentally. Here, returning 42 silently widens the inferred type. An explicit string return type catches the mistake. A practical rule is to annotate exported functions, public APIs, and boundaries between modules. For tiny local callbacks, inference is usually clearer and less repetitive. Avoid the capital F function type, and avoid any when a callback has a known shape. A precise callback type tells TypeScript exactly which arguments the caller will supply and what the callback may return. It also documents the relationship for the next developer. Use an inline function type once, or name the type when the same callback shape appears in several places. Optional and default parameters express different ideas. An optional parameter says that absence is meaningful, and the function may need to handle undefined. A default parameter says there is one ordinary fallback. When that is what you mean, put the fallback directly in the signature. It reduces branching and makes the call contract easier to read. Do not use a truthiness check when 0, an empty string, or false can be valid data. In the first example, age 0 is mistaken for missing input. Check explicitly for undefined instead. This small distinction prevents a surprisingly common class of bugs in optional parameters. REST parameters, arrays, and options objects can represent similar data, but the best choice depends on the call site. Use REST when callers naturally provide separate repeated values. Use an array when the data already exists as a collection. Use an options object when several settings are optional or easy to confuse by position. Clear call sites matter more than clever signatures. Pause and choose. A request always waits 3 seconds unless the caller explicitly chooses another timeout. Which signature communicates that behavior most clearly? An optional parameter, a default parameter, or a REST parameter? The best answer is B. The absence of a timeout does not represent a special state. It means use the normal 3-second value. A default parameter communicates that rule immediately and removes the need for extra handling inside the function. This keyword belongs to JavaScript's call behavior. A regular function receives its context from how it is called, so a callback that runs later can lose the class instance. An arrow function creates no new this value. It carries the surrounding context along with it. Use an arrow callback when later code still needs the current instance. TypeScript lets a standalone function declare the shape required for this. The special this parameter is erased at runtime, but it allows the compiler to check call, apply, and bind. Here the function requires an object with a name. Passing an incompatible context becomes a type error before the code runs. Call, apply, and bind all choose this value. Call invokes the function immediately with arguments listed separately. Apply also invokes immediately, but accepts the arguments in an array or tuple. Bind does not run the function yet. It returns a new function that remembers the context. Enable strict bind call apply in TypeScript, so these arguments are checked precisely. Historically, global access changed by environment. Window in browsers, global in Node, and self in workers. Global. This gives one portable reference. It is useful for feature detection, such as checking whether fetch exists. Avoid adding global state unless there is a strong reason, because modules are easier to test reuse and understand. Functions are objects in JavaScript, so TypeScript can describe a value that is both callable and has properties. The call signature defines how to invoke it, while the language property stores configuration. This pattern appears in libraries and factory APIs. Use it when the API genuinely needs both behaviors, not merely because the type system allows it. Overloads are useful when different input shapes produce different precise result types. If the return is the same, a union parameter is usually simpler. The implementation signature must accept every overload, and callers only see the published overload signatures. Prefer the smallest set that adds real information. Overloads stop helping when the routes become harder to understand than the behavior. A mismatch means the implementation cannot safely handle a published signature. Ambiguity means similar signatures hide the correct call. An explosion means combinations keep multiplying. Replace that tangle with a union, an options object, a generic or separate functions. TypeScript's utility types help contracts stay synchronized. Typeof reuses an existing function's complete type. ReturnType extracts only its result. Parameters extracts the arguments as a tuple. These tools are most valuable when the original function lives in another module or library, and you want related code to update automatically when its signature changes. Second checkpoint, you are writing a wrapper that should accept exactly the same parameters as send email, but the wrapper will return something different. Which utility reuses only the argument list, type of return type, or parameters? The correct answer is circa parameters, extracts the function's argument types as a tuple. A wrapper can spread that tuple into its own signature and choose a different return type. Typeof would copy the whole function type, while ReturnType would copy only the output. Here is the practical checklist. Annotate return types at important boundaries. Give callbacks exact shapes. Use defaults, arrays, and options objects when they clarify calls. Remember that regular functions receive this from the call, while arrows capture it. Prefer unions before overloads, unless overloads add precision. And reuse existing contracts with utility types instead of copying them by hand. Finish with a design challenge. Imagine a function with 3 optional positional arguments, a rest parameter, and 6 overloads. What would you inspect first? Look for arguments that should become an options object, overloads that can become one union, behaviors that deserve separate functions, and a return contract that can be stated directly. If you can simplify the call site without losing type information, you understood the chapter's main lesson.